Torque applications like water pump system, sometimes the load can become unpredictable. The motor can get overloaded and cause the motor to stall. This overloading results in higher current consumption in the motor, which will damage the motor. To prevent this, we have a function named stall prevention. Once enabled, excessive current can be stopped by reducing the speed. To understand stall prevention, we are using pump application as an example. However, it's not limited to this application only. Basically, the motor is pushed to rotate, but the torque exceeds the rating, so the motor starts drawing too much current and still won't be able to reach the desired speed. So the VFD monitors the current, and once the current is higher, stall prevention function starts reducing the motor speed until the current is below the rated. And VFD keeps monitoring while accelerating. If the current moves above the rated, the VFD stops acceleration and keeps the same speed or even reduce until the current gets below the rating. So that was the background. This all need to be enabled first. It can be done by a parameter PRD50. There is a choice of selection. We can select stall prevention during acceleration by enabling the first bit on the right. The second bit from the right is for stall prevention when the VFD is in steady state, which means that once the motor reached the desired speed and due to load condition, torque might build up. So stall prevention will then reduce the speed. And the third bit is stall prevention during deceleration. We will discuss this after a while. First, I will show the demo for stall prevention in action. Here I have the pump which is rated 333 amps, and I made the stall prevention at 105% of the rated. There are 4 levels, which for each we can define different acceptable current level, but I am keeping all 105%. Now at the start, it is accelerating as normal, but as soon as the speed gets near the maximum speed, the pump stalls, and it can be visible by a message on the screen written as STL, which indicates stall. Since stall prevention is enabled, so the drive took the action and started reducing the speed, and you will notice that once the speed is reduced, the current started reducing. Now coming to third bit of stall prevention. This bit is to prevent overvoltage trip. As we discussed before, overvoltage can happen during deceleration. Since during deceleration, motor can start acting as a generator, which will supply back the voltage to the VFD. The DC bus voltage level gets high, and to protect the VFD, it has to trip. With third active bit of stall prevention, this trip can be avoided. As soon as the DC voltage gets higher, the VFD increases the deceleration time. So instead of stopping in 3 seconds, for example, it might stop in 5 seconds or even longer, which all depends on the load condition.